Good afternoon, sir. Myself Subhendu Khatwa, a PMRF scholar from IIT Kharagpur, going to present my work, Financial Numeric Extreme Labeling for XBRL Tagging. So in the left hand side of this slide, I am showing one particular financial report filed by a company called Goldman Sachs. This is called 10K report. In 2019, Securities and Exchange Commission, that is SEC, mandated all public companies to file their periodic financial statements that should contain numerals annotated with a particular taxonomy using XBRL template. XBRL stands for Extensive Business Reporting Language. So this is a XML based language to facilitate the processing of financial information. So in this slide, in the left hand side there is a sentence called and a fair value of $192 million. Here 192 has been tagged with a particular tag, retained interest fair value disclosure. In the right hand side, that is called US GAAP : retained interest fair value disclosure. So the problem statement is as follows. Given a sentence from the 10K report, we have to identify the particular numericals that should be tagged by some XBRL tag. So for an example, upon adoption, the company recorded 2.7 billion of net deferred tax, and these are the complete sentence where 2.7 billion, 128 million and 2.7 billion are the numerics, and the output of what we want. So the 2.7 is tagged with some tag called deferred tax asset liabilities net, 120 is tagged with other assets non-current, and 2.6 with other XBRL tag. So given a sentence, we need to tag the numerical with the proper XBRL tag. This is the problem. Now what are the problem with annotating these numericals? So the process of annotating the documents requires enormous manual effort, because as of 2022 there are total of 17,000 XBRL metrics for the financial reporting. So experts or expert annotators from a company have to go through the document and mark each relevant detail with a relevant XBRL tag matrix, which is very tedious and costly process. So what we are looking for a solution that can reduce the search space for the expert annotators. So we want a system like this. Given a sentence, instead of choosing a single tag from the 70k possible tags, we want to give them some ranked list of some top k tag from which the expert annotators can choose from. For an examples, in this sentence, accounts receivable net of allowances of $114 million, where 114 has been tagged with allowance for doubtful accounts receivable current, which has come in the top 1 rank in our method. So this is the application of the system. We just want to reduce the search space from 17,000 tag to some top k tag. K might be from 5 to 10 or something. So we collected 10K annual documents publicly available on the Secure Exchange site from 2019 to 2021. So this dataset is created from 2,348 public companies, which gives us almost 79 lakh sentences containing 142022 annotated numericals with a label set of 2794. So this is the trend, test and depth slates for our model. So as you can observe, the total number of possible XBRL tag can be 2794, which is huge. Then we looked at the frequency distribution of the labels. So at the y-axis we are showing the frequency of a particular label, and in the x-axis we are just showing the label index, which can be from 0 to 2794. As you can see, this follows a long tail distribution, and our dataset contains many labels where data points are less than 20. So why is this problem challenging? So this is extremely large label dataset which contains more than 2,900 labels. There are large difference in the number of data points for each label makes training for underrepresented data difficult. Like from the frequency distribution, we saw that there are many points where number of data points are less than 20. So for those underrepresented data, the training is difficult. Another challenge is the label names are often very similar to each other. We just analyze the cosine similarity between the BART representation of those XBRL labels, and the analysis as shown below. So the top one having the similarity between the other one with the gold truth has a mean similarity of 0.86, and even for the fifth similar XBRL tag with the gold with the ground truth label having more similarity more than 70%. For an example, let's say you have a gold label for this particular sentence. The company recorded an increase in prepaid expenses and other assets for $308,000 recorded an increase of some other comprehensive income. Having gold label as other comprehensive income loss derivative excluded component increase decrease before adjustment after tax. What we saw for this particular gold level, there are many tags which are very similar. For an example, the other comprehensive income loss derivative excluded component increase decrease adjustment after tax having similarity of 99%. And if the last phrase adjustment after tax changed to after adjustments before tax, then also the tax is more or less similar, or before adjustment tax. So for that reason the problem is challenging. The another reason is that the sentence sometimes do not contain enough context to understand the assign a label to different numericals. So they require very expert annotators to understand. They require the expert domain knowledge in order to identify the tag and identify the numeric and the tag it properly. For an example, look at this sentence. Total reserves nets of the current discount were $2.48 billion and $2.45 billion, where $2.45 billion has been tagged with a particular tag called workers' compensation liability current and non-current. This tag has nothing to do with the sentence context, because sentence context having very low similarity between this tag. So for this reason the problem is very challenging. So our proposed method is a pipeline method. So this is a two-step method. So our pipeline takes as a input a sentence from that particular 10K document. First we built a binary classifier, which is BART based binary classifier model. So given a sentence, it will first identify which of the numericals should be tagged and which of them should not be tagged. Once we classify these numericals into taggable and not taggable, then we applied attention XML framework, which is an extreme classification framework. After modifying some of the architecture, then we finally try to predict which tag should be appropriate for that taggable numeric. So for the binary classifier method, we used BART based sequence to sequence tagger framework, which marks each subword of a sentence with a label indicating whether it can be tagged with a particular XBRL label or not. And we got a 88% F1. So for an example, the related tax benefit related for this sentence, there were three numericals: $6 million, $20 million, $30 million. And our model predicted 21 as correctly, but it failed to predict the 6 million as the correctly, because 6 million the model predicted this should be taggable, but the ground truth was it should not be tagged. So for that reason we having some lower number in the precision, but we got a very good F1 score, which is 90%, almost 88%. Once we identify the which of the numericals that should be tagged, then we just apply the extreme classification framework. It is a classification framework where the problem statement is assigning a label to a text from a list of large label set. It may be often thousands. So from a thousands label set, we want to classify a particular label. However, it does not assign a label to a particular span of text. To overcome this problem, we used local attention and masked the untargeted labels in a particular data point. So the attention XML framework works like this. It builds a shallow and wide probabilistic label tree using the bag of words feature. It uses global embedding. So we did some sort of modification in order to adapt in our framework. We divided the data points into numerous data points with to focus on a label a target numerical value. we replaced globe embedding with the BART embedding. We added local attention on target numericals, and untargeted numericals we replaced by num or shape token. These are the special token. So the competitive method which is published in the state of the art, which is called FINER, this is a NER formulation of the problem, but they evaluated on the dataset containing only 139 XBRL tags. So they took only frequent tags, and it was a BART based NER model, and they released some of the state of the art pretend model. So we evaluated the performance between the FINER and our proposed model. So we used three metric: macro precision and micro precision, and for each of them, but for our case the macro precision, macro recall and macro phone is more important, because we want to treat all the labels equally. It may be frequent labels or it may be infrequent labels, because every labels having the equal importance to the annotators to annotate. We cannot distinguish. So we got a very good macro F1 compared to FINER, but that improvement was not that much. For the macro F1 score, we got 47.54, where FINER was 46.20. But when we analyzed in deep what we got, we did some bucket analysis. For top 100 frequently occurring labels, the FINER was performing well, but for the least 1000 frequent labels, where you don't have much data points, their FINER performance is low. We are getting almost 42.25 macro F1, where FINER is getting only 39.17 score. And essentially, from the application perspective, we are more interested about the hit set K. For the attentional XML pipeline with referent masking strategy we tried, we get almost 90% hit set 5 score. So if we give the rank list of top 5 tag, it will be 90% accurate, and which would be very beneficial for the annotators to annotate from, and it will be beneficial from any manual annotation. So we can automate in that way. So in conclusion, we identified the challenges faced in tagging numericals with labels when the number of labels are more than 2000, which follow a long tail distribution. We have rigorously collected an extensive set of labels which we will release for the community use. In future work, we plan to leverage the tag documentation. So for each of the XBRL tag, there might be some metadata, like some description of that particular tag. We want to incorporate that information to improve the performance of the model in future. Thank you.